In this video, I'm going to be showing you how to do slides 2 through 4 on our Element Builder Pear deck. Okay, so first thing you want to do is go here to Clever. All right, Clever is how we get into our gizmos, and click on your AUHSD account. Here's Clever. All right, you see this little green button that says Gizmos Rostering. Click on that. Should take you straight to Clever, or straight to Gizmos Element Builder. Okay, and I have to click Launch. Okay, and we get this. Now the directions say use the arrows to create an atom with 2 protons, 2 neutrons, and 2 electrons. So deuces are wild, 2 protons, 2 neutrons, and 2 electrons. All right, here's our helium atom. Now, how do I know that? Well, click Show Element Name, Show Element Symbol, Element Notation, Electron Dot Diagram. And because we're going to be getting to the periodic table, go ahead and click Show Group and Period. All right, there we go. This stuff will be, it's important, and we're going to discuss this more on Wednesday. Okay, now what is our question asking? Okay, observe, turn the stuff on, show element symbol, we did that. Element notation, we did that. 3 numbers surround the element, the mass number, the electrical charge. If no number is displayed, the atom is neutral, and the atomic number. Okay, so up here, top left, mass number, bottom left, atomic number, and top right, there would be a charge, but there is no charge since the number of protons is equal to the number, let me do that. Since the number of protons is equal to the number of electrons, then the charge is 0. Okay? If these two numbers are equal, protons and electrons, if they're equal, the charge is 0. Okay. Now, which number is equal to the number of protons in an atom? Well, the number equal to the number of protons is the atomic number. So the atomic number is right here. Excuse me. Let me erase that. And let's color code this. So number of protons is the atomic number, which is down here in the bottom left. Okay. How do you calculate the number of neutrons? Now, look at this. Let me see if I can show you on my whiteboard. So to find the number of neutrons, you take the atomic mass. So the atomic mass in this element of helium, and I want to make that green, I guess. Atomic mass is 4. So to find neutrons, equal to atomic mass or atomic, no, mass number. Mass number minus protons. Okay, so neutrons is equal to atomic mass or mass number minus protons. Okay, so if we have if we have a mass of 4, subtract that from the number of protons, which is 2, which means our neutrons is 2. Okay, so if I give you a question and it says how many neutrons are in carbon 12, okay, you just subtract 12 from the number of protons. All right, so how can you calculate the number of neutrons? We just did that. Which particle, proton, neutron, or electron has a positive charge, negative charge, or no charge at all? So again, let's go over our charges. Let me erase some stuff. Okay, right now this is neutral. It's neutral because these two numbers, make this red. These two numbers, oh, it's pink, I guess. These two numbers are equal. It's neutral. Now, look what happens when I take away an electron. Now it becomes positive. Okay, becomes positive. Why? Because there are more protons than electrons. So protons must have a positive charge. So protons are positively charged. Which one has a negative charge? Okay, well, let's move this electron. Let's add 2 electrons. Okay, well, look, the number changed again. It went negative. Why? Because there are more electrons than protons. So electrons are negatively charged. And which one has no charge at all? We can add as many or take away as many neutrons as we want, and there's still no change. Okay, see, look at this pink circle up here. It's still -1, right? There is a number changing, however. That number is the mass number. However, neutrons have no charge. Okay, that's very important that you understand that. Okay, so that's questions 1 and 2. Let's go to the next one. Okay, analyze. An isotope is an alternative form of an element. Each isotope of an element has the same number of protons. Let me circle this. The same number of protons, but a different number of neutrons. Okay, this is super important too. The isotope is represented by the atomic symbol and mass number, such as helium-4. So the atomic symbol for helium is He, and the mass for helium is 4. Some isotopes are stable, while others are radioactive, which means that the atom decays over time and emits radiation. Okay, we're only looking for the stable isotopes of carbon. All right, the recipe for carbon is, let me erase some stuff. The recipe for carbon is 6 protons, 6 neutrons, and 6 electrons. Let's make it neutral so it's a little easier to understand. So let's get this spooky number up here. And 6 electrons. Okay, put this down for a sec. Okay, so this, how do we know this is an isotope, Mr. S? How do you know this is an isotope? Well, actually, I need this back now. It says right there, stable. This isotope makes up 98.89% of the element. So this is an isotope of carbon. And then we go here, we put on this, you would just write C12. So this is 1A, C-12. Well, that is disgusting. 1A, C-12. Okay, so there's one isotope of carbon, carbon 12, C-12. Is there another? Let's see. Add a neutron, carbon 13. So how am I getting carbon 13? Well, it tells me here, but also add these two numbers together for the mass, okay? Protons plus neutrons, 6 and 7 is 13. And this is, again, stable. All right? So carbon 13 right here. So this is stable. Is there another stable isotope? I don't know. Let's find out. Get to my pointer. Add another neutron. No, this is radioactive. Do not write this one down. No. Let's go the other way. Carbon 11. That's radioactive? No. So only 2. Carbon 12 and carbon 13. Okay. 1B, as for nitrogen, the recipe for nitrogen, 7 neutrons, 7 protons, and 7 electrons. Let's make it neutral. So 7, 7, 7, lucky sevens. And is this stable? Yes. This isotope makes up 99.634% of the element. So nitrogen 14. We have another one. Is nitrogen 15 stable? Let's add a neutron. Yeah, it is. It makes up 0.366% of the element. So N15 is stable. Okay. How did I get 15? 7 protons, 7 neutrons, add them together. Oh, there we go. N15. Add another one. No, this is radioactive. No go. Let's go the other way. No, this one's radioactive too. This is a no go. All right. Now for oxygen. Recipe for oxygen is 8 protons, 8 neutrons, and let's make it 8 electrons too. 8, 8, 8. All right. And this one is stable too. What do you know? So this one is O16. It's 8 and 8 is 16. Add another neutron. O17, that is stable as well. Add another neutron. That one is stable too. So we have 3 for oxygen. Oxygen 16, 17, and 18. So to write the notation, just O dash 16, O dash 17, O dash 18, and same for carbon and nitrogen. C dash 12, C dash 13, N dash 14, N dash 15. Okay. All right. Now let's answer the following questions for number 2. How many electrons are there in a neutral atom of lithium? Okay. There's a recipe for lithium is 3 protons, and let's make it 4 neutrons and 3 electrons. So 3, 4, 3 are the numbers we're looking for. And the question is, how many electrons are there in a neutral atom of lithium? Oh, okay, well, 3 protons. If it's neutral, protons and electrons have to be the same. So again, we're looking for neutral. And if this had a charge, there would be a charge up here in the top left. But there's nothing there because these two numbers, the electrons and the protons, are the same. There you go. Those are both the same. All right. How many neutrons are in an atom of magnesium 25? Okay. So let's see if we can find. Can we do magnesium here? I don't think we can. So I might have to show you here. Let's see. Let's go to P table. Okay, here's periodic table. Oh no, magnesium's 12. I can show you in here for sure. Okay, so let's make it 12 protons. All right, and let's see, what's the mass of magnesium? Magnesium is 24, so 12 and 12. There we go. Let's add some electrons to make it neutral. Now the question is, how many neutrons are there in magnesium 25? Okay, so this is a simple subtraction problem. Magnesium has 12 protons, but I'm asking for magnesium 25. Well, to be magnesium, you have to have 12 protons, okay? If you don't have 12 protons, you're not magnesium. So let's go ahead and let me circle. Nope. Okay, there we go. Now I have magnesium 25, right? So magnesium has 12 protons. And okay, so back up like up here. So the mass is 25. The protons are 12. Okay, so 25 minus 12 is 13. So magnesium 25 has 13 protons. How do we know? Well, we can build it here by first building magnesium, which again, magnesium has 12 protons. There's magnesium. Okay, so build 12 protons and add the rest neutrons, so until this gets to 25. And then that tells you how many neutrons you have. What is the mass number of an atom with 5 protons and 7 neutrons? Okay, this one's super easy. C, 2C, you're just adding them, okay? So 2C, you add 12, sorry, you add 5 plus 7, and you get 12 as the mass number. Simple addition problem. And when an atom is charged, it is called an ion. How many electrons are there in O2 negative? Okay, now let's use the element builder to do this. Let's use the element builder to do this. I want to erase these. Okay, and I want to go to my pointer, and I want to make oxygen. Oxygen has 8. And let's make it... All right, now, the question says, let's make it neutral. So same number of electrons as protons. Okay, and let me circle these two. Okay, now the question says to make it, negative 2 minus. So 2 minus. So there needs to be 2 more electrons than protons. So add 2 electrons, put 2 electrons in, and now we get our 2 minus notation. Okay, so this means that there are 2 more electrons than protons. But why is it negative? Okay, that might be the question you're wondering. It's negative because electrons have a negative charge. So when you're adding 2 negatives, it becomes more positive. When you add 2 negative charges, becomes when you add 2 negative charges, it becomes more negative. Excuse me. Okay, so this oxygen ion has how many electrons? Not 2, has 2 more. So it had 8, and we added 2 more to have a total of 10. So 2C, 2D, 2D is 10 electrons total. Now E is asking, how many electrons are there in magnesium 2 plus? So let's build magnesium. Right, and magnesium has 12 protons, about 12 neutrons. Okay, and says let's make it neutral, but it says to make it 2 plus. All right, so how do we make an atom positive? We take away 2 electrons. Okay, let's take away 2 electrons. Now we're plus 2. Okay, so magnesium plus 2 has how many total electrons? Has 10 electrons right here. That's circled. Okay, so that is slide 3, I believe. Let's go one more. All right. So now I want you to build a neutral hydrogen atom. So neutral hydrogen atom. Neutral hydrogen has, let's just reset this. Neutral hydrogen has 1 proton, 0 neutrons, and 1 electron. See that 1, that plus 1 disappeared because it's neutral. Okay? Now they want us to add electrons to the atom until you have used all the available electrons. Okay, so just keep pressing this until you use all the electrons. All right, look at that. Crazy pattern. Okay, and electrons are arranged in orbits called energy levels. Okay, just like Bohr was talking about. The gizmo shows all the first 2 energy levels, but only part of the 3rd energy level. And there we go. The first 2, so 1, 2. So the inner one, the first orbital has 2. The next one has 8. And the next one has how many? 1, 2, 3, 4, 5, 6, 7, 8. But this is only part of the third orbital. Okay, so how many electrons can fit in the first energy level? And we've seen that right there. So 1, 2. So try to draw a circle around these two. So there's 2 in the first orbital. How many electrons can fit in the second energy level? And we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 total. Let me see if I can draw. My circles are going to be really bad. That's okay. So there's one energy level. And here is the second energy level or orbital. Sorry, my circles are really bad. All right, how many electrons fit in part of the third energy level shown? Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's our atom. So we have 2, 8, and 8 for A through C. 2, 8, and 8. 2 electrons fit in the first energy level, 8 electrons in the second energy level, and 8 electrons in the third and part of the third energy level. Okay, click reset. Let's click reset. Oh, I should be playing it, huh? Play it. And then you can see them spin around when you hit play. All right, let's reset it. Make it neutral by adding an electron to balance out that proton. The electrons in the outermost orbit are called valence electrons, the outermost orbital or outermost orbit, or outermost energy level. Those are called valence electrons. They help create chemical bonds. Let's create a lithium atom with 3 protons, 3 neutrons, and 3 electrons. Okay, so let's make lithium, 3 protons, 3 electrons, and 4 neutrons. And let's erase the rest of this so we can see it. Well, let's do that. So let's erase this stuff. Get out of here. Okay, I want to erase all of it. Erase all of it. So I want to be able to see all those little protons. And I'm going to press play so we can see them spinning around. And this is what they're actually doing. Right, look at those electrons spinning around. Okay. Now, how many valence electrons are there in a neutral lithium atom? Okay. So we're looking for the outermost orbital. All right. Let's draw. Let me just draw the orbitals. And I'm going to hold it here. Nope, it didn't work. Just a quick little ramp. Oh my gosh, that's so bad. That's fine. Okay, so that's one energy level there. The second energy level is right here, right? But in that energy level, we only have 1 electron. Okay, so there's 1 electron in the valence shell or valence orbital of the lithium atom. Okay, so again, this is covered up by my face. Let me move me a little bit. Turn on show electron dot diagram. Valence electrons of an atom are shown in an electron dot diagram. What do you observe? Okay, so this is why I asked you to click this box. You can see the electron dot diagram only shows the valence electrons, only the electrons in the outermost orbital. See that? There's one there and there's one there. It doesn't show the other two because the electron dot diagram is only representative of the valence electrons. Okay, am I done? Yes. All right. So those are the first 3 slides. I know this video is long and that's kind of a lot of information, but this is going to be super helpful going forward, and then you can just refer to this. The next video is going to cover the periodic table. Okay, and I did display a website for you, P-table, and it looks like they actually updated P-table quite a bit. Didn't used to look like this. This is a really great resource for us. It's also in my Bitmoji classroom if you want to take a look at P table. Okay, so I hope this video has been helpful for you. I know it's kind of long, and thank you for bearing with me.